the height of a rectangle is increasing at 3 meters per second, and the length is decreasing at 2 meters per second. Under what conditions is the area of the rectangle increasing? Is increasing, so we're talking about dh dt. Length is decreasing, that means we're talking about dl dt. We're talking about area increasing, so we're talking about dA dt. So we want something relating h, l, and a, and that's easy enough to do. If we've just got a little rectangle, area is length times height. And furthermore, we can just write area as. So we're going to deal with these rates, so let's do our derivatives. Notice this is a product rule, so that means derivative of L with respect to t times h plus L times derivative of h with respect to t, just like that. At dh dt is 3 meters per second. dl dt is decreasing, so it's negative. It's negative 2 meters per second. And we know that area is increasing, so that means that dA dt must be greater than 0. Because an increasing rate, that means a positive derivative. So that means 2h plus L times 3, that's going to give us our dA dt. We know that all of that has to be greater than 0. So now, if we want to figure out under what conditions is the area of the rectangle increasing, all we basically have to do is solve for one of these variables. We aren't going to be able to get these variables worked out any further and define actual numbers, but what this is basically saying is it's saying that for a certain relationship between h and l, if that relationship is true, then the area of the rectangle is increasing. So let's add 2h to both sides. We can divide either way. Let's go ahead and divide both sides by 2. So what this really means is that when h is less than 3/2 L, the area of the rectangle is decreasing because, increasing. Because dA dt is greater than 0.